where n is a rational number. It may be positive integer, negative integer, or a fraction. Limit extends to a of f of x is always equal to function of c. F of x is equal to 2x plus 3 is continuous at x is equal to 1. Now you know what is the meaning of mod x. Modulus of x is nothing but plus or minus x. Hello dear students, welcome to this session of mathematics class. Today I am going to discuss regarding very important chapter in calculus. In calculus you are going to study very important chapters, differential calculus and integral calculus, then differential equations. Now in differential calculus, the first concept we are going to study is limits and continuity. That is continuity and differentiability. In first PUC you might have been studied regarding limits, the continuation of that limits and continuity, and the differentiability. You might have been studied differentiations also. The continuation of differentiations and limits we are going to study in this chapter. This is very important chapter. The first concept I am going to discuss today is the continuity. Okay, now let us come to the definition of a limit. Before going to the exact definition of a continuous function, let us discuss regarding the limits, definition of a limits and algebra of limits and how to evaluate a limit. Then I will go to the definition of continuous functions and the problems based on this. Now, let us, by knowing the definition of a limit, let us discuss regarding the left hand limit and right hand limit of a function. The left hand limit is denoted as the limit. So, I will explain once again. Limit extends to a of f of x is nearly equal to L is denoted as like this. Limit extends to a of f of x is equal to L. That means the value of f of x is nearly equal to L when x is nearly equal to a. Now let us discuss regarding left hand limit and right hand limit of a function. So suppose if let us consider this is x axis and y axis origin. Suppose a curve y is equal to f of x is a curve at this point a, at a. So, if the values of a which approaches towards x from, that is approaches x towards a, the value will approaches x towards a like this, is denoted as left hand limit of a function. Left hand limit, that is denoted as LHL, left hand limit, denoted as limit extends to a minus f of x. So, LHL, limit extends to a minus f of x. The value of f, the values of x, that is the value of x towards left of a, is denoted as limit extends to a minus f of x. That is the left hand limit. Now, this is x axis, y axis. Let us consider the curve. This is y is equal to f of x. This is a. Okay. Now, the value of x nearer to a, that is to the right of a, denoted like this. So, then this is said to be a right hand limit of a function. Limit extends to a of, limit extends to a plus f of x. And that means the value of x approaches towards the right of a, denoted as right hand limit of a function. That is limit extends to a plus f of x. That is the right hand and left hand limit of a function. Now the left hand and right hand limit of a function are equal, then if left hand limit is equal to right hand limit of a function, then we are going to represent it as limit extends to a of f of x. Right. So left hand limit is equal to right hand limit, that's equal to denoted as limit extends to a of f of x. Now, before going to if you know the left hand limit and right hand limit, so we will define the continuity of a function, continuous function, the definition of a continuous function. Before going to the exact definition of a continuous function, let us know regarding the properties which you have studied in limits. So the important properties of limits are limit extends to a of, if a function is like this, constant into function, you can remove constant out and apply the limit for the function. Limit extends to a of f of x. Suppose if the function is like this, limit x tends to a of f of x plus or minus g of x plus or minus h of x, then term by term we are going to apply the limits. Limit x tends to a of f of x plus or minus limit x tends to a of g of x plus or minus limit x tends to a of h of x. This is applying the limits term by term. If it is positive, put positive sign. If it is negative, then it is minus. Now, the third one, if it is quotient, limit x tends to a of f of x divided by g of x, numerator divided by the denominator. You can apply the limit separately for the numerator. Limit x tends to a of f of x divided by limit x tends to a of g of x, provided g of x is not equal to 0. Okay. Now, let us discuss regarding the theorems. There are two important theorems you might have been studied in the previous classes in first PUC limits chapter. The very important first theorem is limit x tends to a of x raised to n minus a raised to n divided by x minus a is always equal to na to the power of n minus 1, where n is a rational number. It may be positive integer, negative integer, or a fraction. Now, the very important second theorem is sandwich theorem, that is limit theta tends to 0 of sin theta by theta is always equal to 1. Or you might have been studied limit theta tends to 0 of tan theta by theta is also equal to 1. So these are very important properties which we are using for solving the problems. Now, I will take one small example. For example, evaluate limit x tends to 1 of x square plus 4x plus 3. Now, just put the value of, put x is equal to 1 in this function. Then this becomes, this implies 1 square plus 4 into 1 plus 3. So, what is this equal to? That is 1 plus 4 plus 3. This is equal to 8. The value of f of x is equal to 8 when x is nearly equal to 1. Suppose if it is like this, limit x tends to 2 of x square minus 4 divided by x minus 2. By putting x is equal to 2, what you will get? You will get 0 by 0. 0 by 0, which is an indeterminate form. 0 by 0 is an indeterminate form. So this can be solved using this formula, or so this can be written as, this implies limit x tends to 2 of x square minus 4 can be written as 2 square divided by x minus 2. So using this concept, limit x tends to a of x raised to n minus a raised to n divided by x minus a is equal to na to the power of n minus 1. Here n is equal to 2, we can write 2 into a is 2 to the power of 2 minus 1. 2 into 2 power 1, that is nothing but 2 into 2 is equal to 4. So the value of limit is equal to 4. Okay. Suppose if you want to evaluate like this, limit x tends to 3 of x cube minus 27 divided by x minus 3. Now, even if you put x is equal to 3, you will get 0 by 0, which is an indeterminate form. This can be evaluated. Just limit x tends to 3 of x cube minus 27 can be written as 3 cube divided by x minus 3. Again, this is of the form limit x tends to a of x raised to n minus a raised to n divided by x minus a. N is equal to 3. A is also equal to 3. N a to the power of n minus 1. That is equal to 3 into 3 to the power of 3 minus 1 is 2. 3 into 3 square is 9, 3 is 27. The simplified answer for this is 27. Now, suppose if the problems are like this. Evaluate limit theta tends to 0 of sin 3 theta divided by theta. How to simplify this? So, just here limit theta tends to 0. Just multiply by 3 and divide by 3 sin 3 theta divided by 3 theta. 3 into, if you observe carefully, this is of the form limit theta tends to 0 of sin theta by theta is equal to 1. You know limit theta tends to 0 of sine theta by theta, which is always equal to 1. So 3 into 1 is equal to, this is how we are going to solve the problems. Okay, now let us come to the exact concept. Now let us discuss regarding the continuity. So suppose f is a real function and let c be the point in the domain of f. Suppose if f is a real valued function, if f is a real function and c be a point on its domain, then f is continuous if limit extends to a of f of x is equal to function of c. Limit extends to a of f of x is always equal to function of c, then we can say the function is said to be continuous. The function is continuous at the point, the continuous limit f of x is said to be continuous. In general, what is the definition of limit extends to f of x means left hand limit and right hand limit are equal. So in general, if left hand limit LHL and the right hand limit RHL of the value of the function at x is equal to c, the left hand limit and right hand limit of the function at x is equal to c exists. If it exists and is equal to, and each of that and exists and equal to each of each other, then it is said to be continuous at x is equal to t. If the function is continuous means the limit of the function at x is equal to c exists and equal to each other, in the sense left hand limit and right hand limit are equal, and then that is also equal to the functional value f of c, then f is said to be continuous at x is equal to c. In general, a function f of x is said to be continuous if left hand limit is equal to right hand limit is equal to functional value. The right hand limit and the left hand limit of x is equal and coincides. So if equal to c and coincides, then we are going to represent it as left hand limit is equal to right hand limit is equal to f of c. Then the function is said to be a continuous function. So in general, a function f of x is said to be continuous, if left hand limit is equal to right hand limit is equal to the functional value. So is said to be continuous at x is equal to a. Now what is the meaning of left hand limit is equal to right hand limit is equal to f of a? Here left hand limit is limit x tends to a minus f of x is equal to limit x tends to a plus f of x is equal to f of a. If these three conditions are satisfied, that is left hand limit is equal to right hand limit is equal to functional value, then f of x is said to be a continuous function. So in general, a function f of x is said to be continuous if the left hand limit is equal to right hand limit is equal to the functional value, then f of x is said to be a continuous. Otherwise it is said to be a discontinuous function, not continuous. Now let us discuss in detail. A function is continuous at x is equal to c if the function is defined at x is equal to c, and if the value of the function at x is equal to c is equal to the limit of the function at x is equal to c. So if the value of the function at x is equal to c is equal to the limit of the function at x is equal to c, then f is said to be continuous at c. We say f is discontinuous at c if c is called the point of discontinuity. If it is discontinuous means then point C is called the point of discontinuity. Now let us take an example. Let us come to the problem. I will take one problem. Let me check the continuity of the function f is given by f of x is equal to 2x plus 3 at x is equal to 1. Now let us find out the value. What is given? F of x is equal to 2x plus 3. Now just find out f of 1. Put x is equal to 1. Then you will get f of 1 is equal to 2 into 1 plus 3, that is equal to 5. Now find out the limit x tends to a of f of x. So this is equal to limit x tends to a. What is a here? A is nothing but 1. A is equal to 1. Limit x tends to 1 of f of x. What is f of x? Is 2x plus 3. So this is equal to, substitute the value of x is equal to 1, 2 into 1 plus 3, this is also equal to 5. So what do you say? Limit x tends to a of f of x is equal to f of a, that is 5 is equal to 5. So the limit value is equal to the functional value, therefore f of x, this given function f of x is equal to 2x plus 3 is continuous at x is equal to 1. Is continuous at x is equal to 1. So just find out f of 1. What is f of x? F of x is equal to 2x plus 3. Put x is equal to 1. F of 1 is equal to 2 into 1 plus 3, 5. Again, here at a is equal to 1, limit x tends to a of f of x can be written as limit x tends to 1 of f of x is 2x plus 3. Put x is equal to 1. 2 into 1 plus 3 is equal to 5. So the functional value is equal to limit x tends to a of f of x is equal to f of a, 5 is equal to 5, hence f of x is a continuous function. F of x continuous at x is equal to 1. Okay. Now, let us come to the next problem. Next, examine whether the function f is given by f of x is equal to x square is continuous at x is equal to 0. Now, what is given here? At x is equal to 0, this is a is equal to 0. F of x at x is equal to 0, f of x is equal to x square, substitute the value of 0, this is 0 square is equal to 0. Again f of x is equal to x square, let us consider the limit x tends to a of f of x is equal to limit x tends to, what is a? Here 0 of f of x, x square, this is again 0 square is equal to 0. That means limit x tends to a of f of x is equal to f of 0, 0 is equal to 0. That means therefore this f of x is equal to x square is continuous at x is equal to 0. See here, at x is equal to 0 means at a is equal to 0, at a is equal to 0, f of x is given x square, put x is equal to 0, f of 0 is 0 square is 0. Again f of x is x square, therefore the value of limit x tends to a of f of x is equal to limit x tends to 0 of x square, put x is equal to 0, 0 square is equal to 0. So that is limit x tends to a of f of x is equal to f of 0, that is 0 is equal to 0, therefore f of x is continuous at x is equal to 0. F of x is continuous at x is equal to 0. Now let us come to the next problem. So discuss the continuity of the function f given by f of x is equal to mod x at x is equal to 0. Since you know modulus function is nothing but plus or minus x. Plus x if x is greater than or equal to 0, minus x if x is less than 0. Let us define this f of x is equal to mod x means plus or minus x, that is f of x is equal to plus x if x is greater than or equal to 0, minus x if x is less than 0. Now here we can easily find out the left hand limit as well as the right hand limit. If x is less than 0, f of x is minus x. If x is greater than 0, f of x is plus x. And if x is equal to 0, f of x is also equal to x. Now let us come to this. At x is less than 0, what is f of x? F of x is equal to minus x. So straight away you can write left hand limit x tends to 0 minus f of x. This is limit x tends to 0 minus, what is f of x here? Minus x. So this is minus 0 is nothing but 0. Similarly, when x is greater than 0, what you will get? F of x is equal to plus x. So the right hand limit RHL is equal to limit x tends to 0 plus f of x. So that is limit x tends to 0 plus, what is f of x is x, this is equal to 0. So left hand limit is equal to 0, here right hand limit is also equal to 0, and come to the functional value. When x is equal to 0, f of x is equal to 0, f of 0 is equal to 0. Hence limit x tends to a minus f of x is equal to limit x tends to a plus f of x is equal to functional value. That is left hand limit is equal to right hand limit is equal to functional value. All 0 is equal to 0 is equal to 0. So therefore the function f of x is continuous at x is equal to 0. So the modulus function is continuous at x is equal to 0. Very simple. See, let f of x is nothing but plus or minus f, mod of x is plus or minus f, x if x is greater than or equal to 0, minus x if x is less than 0. When x is less than 0, f of x is equal to minus x. So the left hand limit is limit extends to 0 minus f of x is limit extends to 0 minus of f of x is minus x minus 0, that is nothing but 0. When x is greater than 0, f of x is equal to x. The right hand limit is limit extends to 0 plus f of x. Limit extends to 0 plus f of x is equal to 0. Right hand limit is also equal to 0. When x is equal to 0, f of x is equal to 0, that is f of 0 is also equal to 0. Hence, left hand limit is equal to right hand limit is equal to functional value 0 is equal to 0. Hence, f of x is continuous at x is equal to 0. Okay, hope you followed this. Now, let us come to the next problem. Same type. Show that f of x is equal to x cube plus 3 if x is not equal to 0 and 1 if x is equal to 0 is not continuous at x is equal to 0. Now, what is given here? F of x is equal to x cube plus 3 at x is not equal to 0. When x is not equal to 0 means x is not equal to 0 in the sense x is less than 0 or x is greater than 0. So therefore we can write limit extends to a of f of x. So what is a here? A is equal to 0. So this can be written as limit extends to 0 of what is f of x? F of x is x cube plus 3. So this is equal to, put x is equal to 0, 0 cube plus 3 is equal to 3. Again, when x is equal to 0, when x is equal to 0, f of x is given to be 1, f of x is equal to 1. So f of 0 is equal to 1. Now therefore, what do you say here? Therefore, limit extends to 0 of f of x is equal to f of 0. See, check whether 3 is equal to f of 0 is 1. So 3 is not equal to 1. This is not equal. So left hand limit and right hand limit are equal but not equal to the functional value. So limit extends to f of x is not equal to f of 0. Therefore, f of x is not continuous. F of x is not continuous. This is not continuous at x is equal to 0. This is not continuous at x is equal to 0. That means this is a discontinuous function. Discontinuous functions. Here, x is not equal to 0 means x is less than 0 or x is greater than 0. Therefore, you can write limit extends to a of f of x is equal to limit extends to 0 of f of x is x cube plus 3. So this is 0 plus 3 is equal to 3. Again, when x is equal to 0, f of x is given to be 1, f of 0 is equal to 1. So limit extends to 0 of f of x is equal to f of 0, that is 3 is not equal to 1. So therefore f of x is not continuous, this is discontinuous, not continuous at x is equal to 0. Now let us come to the next problem. Same type problem. What is the problem? If f of x is equal to x plus 2, if x is less than or equal to 1, x minus 2 if x is greater than 1, check the continuity of the function. So check the continuity of the function. See, what are the values given? X is less than or equal to 1 and x is greater than or equal to 1. So now let us come to this. When x is less than 1, when x is less than 1, what is f of x? When x is less than 1, f of x is equal to x plus 2. When x less than 2 means right away we can take left hand limit. Limit extends to a minus f of x. What is a here? A is equal to 1. So this is limit extends to 1 minus, what is f of x? F of x is equal to x plus 2. Put x is equal to 1. 1 plus 2, this is equal to 3. Left hand limit is equal to 3. Now let us come to this second part. When x is greater than 1, what is f of x? F of x is equal to x minus 2. Now according to the definition, right hand limit is equal to limit extends to a plus f of x. So this is limit x tends to a plus a, what is a here? 1 plus f of x is x minus 2. Substitute the value of x is 1 minus 2. 1 minus 2 is equal to minus 1. The right hand limit is minus 1. Now let us come to the functional value. What is functional value? When x is equal to 1, when x is equal to 1, f of x is equal to x plus 2. When x is equal to 1, f of x is equal to x plus 2. So therefore, f of a means f of 1, that is nothing but 1 plus 2. This is equal to 3. Now write down what is left hand limit, what is right hand limit, and what is functional value. So left hand limit is 3, right hand limit is equal to minus 1, and the functional value. So they are not equal. Left hand limit is not equal to right hand limit is not equal to the functional value. Therefore, f of x is not continuous. This is a discontinuous function. This is not continuous. This is a discontinuous function. So check the continuity whether it is continuous or not. So when x is less than 1, when x is less than 1, f of x is equal to x plus 2. According to the definition, we will get the left hand limit. The definition of left hand limit is limit x tends to a minus f of x is equal to limit x tends to 1 minus x plus 2. That is, put x is equal to 1 plus 2 is equal to 3. Left hand limit is equal to 3. When x is greater than 1, when x is greater than 1 means f of x is equal to x minus 2. According to the definition, right hand limit is limit x tends to a plus f of x is equal to 1 plus f of x is x minus 2. Put x is equal to 1 minus 2 is minus 1. Left hand limit is 3 and the right hand limit, this is left hand limit. Left hand limit is 3 and right hand limit is minus 1. So when x is equal to 1, f of x is equal to x plus 2. F of a is equal to f of 1. So that is 1 plus 2, these 3. Left hand limit, right hand limit and functional value are not equal. So 3 is not equal to minus 1, that is all not equal to 1, 3. Therefore, f of x is not continuous, hence it is a discontinuous function. Now let us come to the next problem. Find the point of discontinuity of the function. Now here, what is required to find is the points of discontinuity of the function and is defined by f of x is equal to x plus 2 if x is less than 1, 0 if x is equal to 1, x minus 2 if x is greater than 1. Check the continuity of the function. The point of discontinuity and check the continuity of the function. Now, what is given when? Let us find out. When x is less than 1, f of x is equal to x plus 2. So, when x is less than 2, according to the definition, we will get the left hand limit, limit x tends to a minus f of x. What is a here? A is equal to 1. Now, this is limit x tends to 1 minus f of x is x plus 2. Put x is equal to 1, 1 plus 2 is equal to 3. The left hand limit is equal to 3. Now let us come to this. When x is equal to 0, f of x is given to be 0. So that is f of 0 is equal to 0. Now when x is greater than 1, what is given? F of x is equal to x minus 2. According to the definition, you will get the right hand limit. Right hand limit is limit x tends to a plus f of x. So this is equal to limit x tends to 1 plus f of x. What is f of x? X minus 2. So this is 1 minus 2 is equal to minus 1. Right hand limit is also equal to minus 1. So what is saying? Now therefore, the left hand limit is equal to right hand limit is equal to functional value. Left hand limit is 3, right hand limit is equal to minus 1 and the functional value is 0. These three are not equal. Therefore, the function is discontinuous. Therefore, the function is not continuous at x is equal to 1. It is discontinuous at x is equal to 1. So, therefore, x is equal to 1 is only the point of discontinuity. Therefore, x is equal to 1 is only the point of discontinuity of this function f of x. That's all for the day. Let's meet in the next class with different problems based on continuity. Thank you very much. Thank you.